Hi everyone, and welcome to our Germination Strategy Session webinar. Today we'll be looking at innovations in alfalfa seed. My name is Mark Zinkowitz. I'm the editor of Germination, and today I'll be serving as your moderator. First, I'd like to thank our sponsors, 2020 Seed Labs and CCAN, for their support. I'd also like to note a few housekeeping items. This webinar is being recorded and will be made available on germination.ca following the event. Today we have three speakers talking about innovations in alfalfa seed. We have Todd Hyra, Annie Claussens, and Eric Dick. For audio quality purposes, all microphones have been muted with the exception of speakers. After each speaker finishes their presentation, there will be an opportunity for questions. If you have a question or comment, please share them in the chat box on the bottom left side of your screen and let us know who they are directed to. We certainly welcome your input. Today we have someone who's no doubt familiar to many of you. Todd Hyra is Business Manager, Western Canada for CCAN. He's responsible for developing new business opportunities for CCAN members and industry partners. Todd will provide a short history of the alfalfa seed industry over the past few years and talk about how it's changed, and he'll also highlight some of the varieties offered by CCAN. So let's get started. Over to you, Todd.
Thank you very much, Mark. Yes, I first wanted to set the stage, I guess, by explaining how things have evolved over the last, I'd say, 20 years. I spent a lot of time early in my career involved in forage product development and product line management. And back at the beginning of my career, the industry was much different. There were more players, more smaller forage companies, and quite often products were shared because there was not a lot of proprietary genetics available at the time. Quite frequently, varieties that were released by public programs were often shared across a wide number of forage companies, so that one variety may be sold by 20, 30, 40 different companies. And so quite often these products would have been either shared through the Canadian Seed Trade Association, had a forage seed project where stock seed was distributed to anyone interested in supporting those products. And then once CCAN was developed, many of those products were shared by CCAN members and were represented by a wide range of members across the country. If you fast forward to today, we have fewer, larger, specialized forage seed companies, and with that, a desire to have differentiated product lines so that they can support those products in a unique way, be able to sell their own unique product under their brand, and not necessarily compete head-to-head with another company that may have exactly the same product on the same shelf. And so that's been a major change, which I think has boosted the quality of the products that have been coming forward over the years and allowed differentiation in the marketplace. I have a couple slides just to show why that used to work within CCAN. This is the 2017 map of CCAN membership across Canada. So 660 plus members from coast to coast selling products makes a very broad network to work from. If you want to look specifically at Western Canada, over 500 members covering just about every geographic area of Western Canada. So within a very close proximity to pretty much every producer, there was a seed grower. And historically, many of those grew, processed, and sold alfalfa and other forages directly to their customers. And so now that's more handled by larger organizations that are able to grow product centrally and move it into place. So we look at some of the products we had in the past, and one of our first products very early on in CCAN was Rangelander, a creeping-rooted variety developed by Agriculture Canada, very broadly adapted, tough, worked well under dryland production for long-term stands. This is one of those types of products that was shared throughout the industry and often grown by many different regional seed companies, sold and supported by them. Another product not far after that was Peace Alfalfa. It was developed under heavy cutting pressure in Fort Vermilion, Alberta, originally released in 1980, but this one's still in production, so excellent winter hardiness, and because it was selected in the piece, there's still a very loyal following to this product even today. So this is one that a new breeder increase has just gone in the ground and is still available to those interested in participating in this product. Looking forward to some of the newer products that we have available. These ones have not been picked up broadly. As I mentioned, many of the companies that are supporting products often have their own proprietary brands and don't necessarily share the genetics the way that, not interested in sharing products that come through CCAN, but they are available, and any one of our member companies are certainly available to them. First product is Dalton. AC Dalton, developed by Agriculture Canada and Lethbridge. It's has a really good fit under irrigation specifically, with high forage yields under irrigation. So it's really a maximum productivity alfalfa. The next product that I wanted to mention quickly is AC Totem. This variety was developed by AAFC in Quebec City, and it's more of a broadly adapted product and can fit pretty much any traditional production region in Canada. The reason we looked at Totem, or we like Totem, is it's a unique combination of strong forage yield but very good winter hardiness. And so in most of the production areas of the prairies, looking at pure stand alfalfa, higher production conditions, AC Totem is a great fit. Same vintage as Totem is AC Manitou, also a traditional trifoliate developed by the same program by Riel Michaud at AAFC in Quebec City, and similar to Totem in terms of its yield, and also similar in fall dormancy. So once again, one of these products that fits well under high production systems and typically in pure stand alfalfa. Next product that I wanted to just snapshot briefly is AC Bridgeview. This one was developed by Agriculture Canada in Lethbridge by Surya Churia, and this one's unique because of its selection under saline conditions. So the variety is, well, it's not going to handle the really extreme salt conditions. It's going to have improved establishment under moderate saline conditions. So getting that taproot into the soil and getting the alfalfa established is going to help manage the salt longer term. So this, in combination with salt-tolerant grass species, can be an effective management tool to help helping reduce the impact of salinity. So this variety is in breeder seed increase right now, and we're hoping to have this one available to members in the next season or two. So once again, it's not in the market quite yet, but we hope to have it in the marketplace in the near future. Next variety is a unique variety. It's called AC Yellowhead. It's a falcata. It's an extremely winter hardy variety, and it's not exactly new. We've had it in the marketplace for a number of seasons, but it's a tough one to produce, and so the variety has been slow to get to market. Right now it's being produced by Golden Acre Seeds in Fairview, Alberta, and they have been doing the exclusive production of this product for the last several years, and getting to the point where it's a little more stable supply is available. So these ones, I have experienced this one over the last 10 years, and it's one of those alfalfa products that can withstand some very tough grazing pressure, extreme drought, but there is a challenge to establishment. And so it's not a great seed producer. For that reason, it's been traditionally fairly expensive, but the duration of the stand is quite amazing. In the late 90s, I was working with this variety, and as in grazing trials that were established over a 3-year period, when traditional tap and creeping rooted varieties were dying out, and being reduced by the grazing pressure, this one was strengthening each year as the stand continued to have grazing pressure. So amazing longevity and tolerance to extreme conditions, but once again, slow to establish, and relatively expensive seed in comparison because it's a difficult low seed producer. So just wanted to give a little bit of background to SECAN's history in alfalfa and highlight quickly some of the products. So this is the list of products in the marketplace, either that are currently available from SECAN. Some of them are very lightly produced, but if there was a strong interest by any regional forage seed company, SECAN member could source these products from SECAN. Also wanted to point out a few of the newer forage varieties that are coming from SECAN or in the marketplace right now. And I know it's an alfalfa presentation, but just wanted to highlight a few of these. Also available are Armada meadow brome, Admiral meadow brome grass, Killarney orchard grass, AC Pratt Timothy, and New Kirk crested wheatgrass. All of these developed by Agriculture Canada, all available as a general release through SECAN. So some good genetics for seed companies that may be interested in participating in these products. In addition to some of our newer products, we've got some long-standing, as I call them, established forages because they've been in the marketplace for a very long time and are some of the standards in the industry. And so these are represented by SECAN. That list includes Fleet meadow brome grass, AC Goliath crested wheatgrass, Kirk crested wheatgrass, Swift Russian wild rye, Norgold sweet clover, and Nova Sandpoint. It's pretty hard to find these days, but also part of that list. So that's a quick rundown of SECAN from a historical perspective. I'll turn it back to the moderator.
Thank you very much, Todd. If you have any questions for Todd, please type them in the chat box now. You'll find that on the bottom left-hand side of your screen. We'll now commence with a Q&A portion of our webinar. Todd, can you recap for us why there are fewer forage seed companies in Canada today?
Well, the simplest reason would be consolidation. Much like consolidation is happening in other industries, agriculture, as we all know, there are fewer and larger farms, fewer and larger seed growers, fewer and larger seed companies. And so it's really about consolidation and focus. And so it became more productive for larger companies to specialize, and that's really what it's come down to, is those companies specializing in forages rather than having everybody trying to be all things to all people.
In your experience, Todd, what are the major differences between public versus private breeding programs?
Well, I guess the biggest piece would be proprietary programs can really focus on the commercial aspects of what is going to sell in the marketplace, whereas a public breeder can take maybe a longer-term view and do germplasm development that may be beneficial to public and private programs over a longer period of time. So the only way a private breeding organization survives is by getting new products into the marketplace. And so there's a constant push to have new and improved genetics there, whereas a public breeding program could take a longer-term view and do some germplasm development that may enhance the industry longer term.
I have a question regarding our presentation today. Yes, the full presentation will be available at germination.ca within 48 hours, so be sure to watch for that. Todd, are there any winter active varieties bred in Canada?
No. So in terms of the highest fall dormancy ratings that we would normally see from breeding programs coming out of Canada would be 4s. I'm not sure if there's any 5s. Any of the winter active or non-dormant varieties would typically come from U.S. breeding programs.
Well, thank you very much, Todd, for your presentation. I'd like to switch over to Annie Claussens now. Annie is going to talk about her forage breeding and research program and the three main areas it focuses on in terms of improving alfalfa. Annie does her research at Agriculture and Agri-Food Canada's Quebec Research and Development Centre, where she is part of a multidisciplinary team of researchers. You have the floor, Annie.
Thank you, Mark. Sorry. So at the Quebec Research and Development Centre, we have 9 researchers working exclusively on forages, going from nutritional value of ruminant fed to agronomy and breeding. So in the breeding program, it involves 4 scientists. I'm the forage breeder. I work in close collaboration with Annick Bertrand, who's a forage physiologist and biochemist, Solène Rocher, who's working on molecular genetic, and Patrice Oudy, who's working on forage pathology. And we have 9 research assistants which help us develop new forage germplasm. So we have also a lot of collaborators across Canada and in the United States who works with us in breeding new forages. So our forage breeding program is aimed mainly at dairy and beef industry, and the forage species that I work with, it's mostly alfalfa and timothy, but I also collaborate a lot with other breeders on red clover, orchard grass, and brome grass. The main strategic objective of Agriculture and Agri-Food Canada is to increase the productivity of forages through increasing the persistence, the yield, and the nutritive value. Therefore, the alfalfa breeding program that I lead is aimed at increasing the persistence, the yield, and nutritive value, which are the 3 pillars of the alfalfa productivity. So the persistence is mainly funded by Agriculture and Agri-Food Canada, and we target mainly the winter survival. The traditional way to increase winter survival is to put a nursery of alfalfa in the field and wait for a test winter. Test winter is winters which are harsh enough to kill most of the plants, but not all the plants. So you can select within this nursery the most vigorous plants, cross them, and reseed a new nursery. So it's a long process, it's costly, it's unpredictable since you have to wait for winter tests. Therefore, we identify that winter survival is a complex trait, but in Quebec, in Eastern Canada, the main factor affecting winter survival are freezing tolerance and disease resistance, mainly the root rot diseases. Therefore, we developed abiotic and biotic stresses approaches which can be applied indoor to accelerate our breeding program. So those are reliable applications of successive cycle of recurrent selection under controlled conditions. These approaches can be applied to various perennial species, and they allow us to develop new populations that can be used after that to uncover molecular markers which could be inserted in the breeding process. So here for the improving the freezing tolerance, the protocol that we use is that we put 1,500 genotypes that we allow to grow under controlled conditions for 5 weeks. We transfer them after that for 2 weeks at 2 degrees Celsius, and after that 2 weeks also at -2 degrees Celsius for the acclimatation of the plants. After that, we proceed with the freezing stress, which is we progressively decrease the temperature to approximately the LP50, with the lethal temperature for 50% of the population. After that, we transfer them back to the growing chamber for 5 weeks, and we apply after that another stress. So we do it 3 times in a row. And after that, we select the 100 plants which are better performing, intercross them to produce the population. It takes about a year to produce 1 cycle of selection after 3 freezing stress. So here you can see the growth chambers where the plants are being kept to grow. And after that, you can see also the walking freezer where the freezing stress are applied, and the differential survival of the plant, which allow us to identify the plants which have a higher freezing tolerance. And after that, we transfer them to the greenhouse and we end cross them, and make crosses. So here, we evaluate the population under controlled conditions. In alfalfa, you can see the base population APK and the improved population TS6, which has been through 6 cycles of selection for freezing tolerance. You can see that here that the freezing tolerance was at -16 in the base population, and it's improved at about -24 after 6 cycles of selection. In red clover, with the similar thing in Christie background, and we went from -10 to -16. So we were able to improve by more than 5 degrees Celsius the freezing tolerance of these populations. After that, we wanted to know if we affected the winter survival of these populations, and we were able to see that after a winter test, that our base population APK had suffered more than a TF1, the APK, which is 1 cycle of selection and 4 cycles of selection. Here you can see the difference in winter survival. In another background, evolution over here, you can see that most of the plants died compared to the population which has been selected after 2 cycles of selection. So we're able to improve the freezing tolerance of alfalfa, and it had a great impact on its winter survival. Improving the root rot diseases, the methodology that we've developed is using, again, 1,500 genotypes that we allow to grow for 10 days under controlled conditions. We float them for 3 days with the inoculum of the pathology, the disease, and we let them grow for 2 weeks after that. And we select the 100 most vigorous plants, and we cross them to produce the population. And we can do this again and again, and about 3 selection per year we've been able to do. So it accelerates a lot the selection for root rot diseases. So here you can see in the greenhouse the seedlings, which are with the inoculate solution. Here you can see the differential survival of the plants, and after that we cross them, and we can do as many cycles as we need. After that, you can see here the base population, which was highly susceptible, low resistance, and after 3 cycles of selection, we were able to improve its resistance to Phytophthora, and it's now considered a highly resistant population. So in the field here, you can see again the base population, the survival rate, compared to the improved population for Phytophthora. So we are able to improve the root rot diseases resistance with these techniques and improve their survival. So the second pillar of alfalfa productivity is yield, which is funded mainly by the Beef Research Cluster. So the total annual yield of any crop dictates its economic return. So we're trying to increase the fall yield of alfalfa by reducing its fall dormancy. So here you can see we use one background, and this background was peas, and we were able to indoor select for a lower fall dormancy, and we were able with our test indoor to discriminate between the more dormant and the less dormant. We selected those plants and we produced a population, and in Lacombe they were seeded at 5 seed sites around across Canada, and at Lacombe here you can see the difference between the peas and the D1Ps, which has lower dormancy in the yield. And here in Quebec City, in the fall, you can see after the last cut, after 1 week, there's the base population and the improved population, which has already started growing back. So we are able to increase the yield of these populations, and the third pillar of the alfalfa productivity is the nutritive value. This topic is mainly funded by the Dairy Research Cluster. We have two main strategies. The first one is to increase the non-fiber carbohydrate concentration, and the second is to increase the cell wall degradability. The non-fiber carbohydrates are composed of water-soluble carbohydrates, the starch and the pectin. Well, the cell wall degradability aimed mainly at the hemicellulose is cellulose degradability of the cell wall. So we use a nursery of alfalfa, which has been for the third production year, and we selected the plants which were the most vigorous ones. We cut them, ground them, and scanned them with the near-infrared reflectance spectroscopy to determine which one were more representative of the population to the wet lab analysis. We analyzed non-fiber carbohydrate concentration and cell wall degradability of these samples. We predicted these components in all the population and selected the ones which had the higher non-fiber carbohydrates and the higher cell wall degradability, intercrossed them within each of these traits to produce the population. So here you have some results that have been forwarded by one of our previous projects on producing alfalfa for ethanol production, and these populations were selected at the full bloom stage, and were able to improve by 15% the degradability of the cell wall with this protocol. So now we're trying to see if in this population that we've developed, we're able to improve also, but at the early stage of flowering or late bud stage. So we're now at our third cycle of selection for this trait. And for increasing energy, within one recurrent selection, we're able to increase by 5% the energy content of the plant in alfalfa without affecting the biomass yield. We're now at the second cycle of selection for this trait. So within 5 years, we will have developed germplasm, which have higher persistence through higher freezing tolerance to root rot diseases resistance, and higher yield through lower fall dormancy. And we also have developed population which have both higher persistence and higher yield. And we'll have developed germplasm for higher nutritive value by selecting for energy and or cell wall degradability. Thank you very much.
Thank you very much, Annie. If you have any questions for Annie, please type them into the chat box. Again, that's on the bottom left-hand side of your screen. We'll now commence with a short Q&A session. Annie, how can winter hardiness be improved while keeping fall dormancy the same?
There's a link between these two traits. However, it's not absolute. Bremer and some collaborator in 2000 were able to produce an F1 population which has a small negative genetic relationship between these two traits. So by selecting for recurrent selection, we are able to produce populations which are really divergent, well different from the base population. And by developing molecular markers which are correlated with these differences, we may be able to dissect the genetic control of these traits and select for both traits independently.
Annie, can you recap how your efforts are focusing on increasing resistance to various kinds of root rot?
We've been working on Phytophthora root rot here for 4 years now, and we've developed some molecular markers which are related to the resistance of this disease. and we've developed already some population using the methodology that I just presented. And now we're focusing on Aphanomyces race 1 disease. These two diseases are the main diseases affecting the root rot in our harsh, cold, and humid climate here in eastern Canada.
Well, thank you very much, Annie. I'd like to switch over to our final speaker of the day, Eric Dick, to talk about alfalfa innovations from a private seed company perspective. Eric is Forage and Turf Product Manager for Brett Young Seeds. He's worked in various roles across the company, including seed production, territory sales manager in southern Alberta, and also served as regional sales manager in the Peace region. Eric has a master's in business with a specialization in food and agribusiness. Take it away, Eric.
Well, thank you very much, Mark and Germination, for putting on this webinar. I guess alfalfa and some of the forages can often be overlooked when you compare to some of the other cropland agriculture that's going on. And case in point, you'll notice that my cover page is actually a field of canola if you look very closely. Unfortunately, at Brett Young, we don't have an alfalfa cover slide, and it is a priority product for our business. So today, I think I'm going to build a little bit on Annie and Todd's presentations, and hopefully this is a nice complement to what they discussed. Talk a little bit about the evolution to proprietary alfalfa, touch on some fall dormancy and winter hardiness, and what the type of sales we typically see through the Canadian market. As well, look a little bit at some of the new traits, such as rooting habits and low-lignin alfalfas. When I refer to traits here, I'm not talking about traits in the sense of genetically engineered. These are more characteristics that would be achieved through traditional breeding methods. The transition to a proprietary market is driven by the use largely of varietal alfalfa. Varietal alfalfa offers several benefits to growers. One is defined performance. You understand what the yield profile looks like, the standardized quality, and to a certain extent persistence. And those are the typical package that you look at with any alfalfa variety. Then beyond that, you also earn certified seed, where you're going to have standardizations in terms of purity, germination, as well as verified kind. And then lastly, that third category that I have over there, that box right here that says traits, you look at things such as rooting habit, multifoliate or multi-leaf expression. And then something that's been in the news more recently is low-lignin, which I'll talk about a little later on in this presentation. So looking at proprietary alfalfa, when you commercialize an alfalfa variety, it certainly comes with risks. There's the initial breeding risk or investment that needs to take place before you have material that you're able to move forward with. And then once you find a good variety, there comes in the seed production risk. Is it a viable or high seed yielder that can be cost effectively produced? Then with that comes, is the seed sufficient quality to sell through the channels that you have it targeted for? And with alfalfa, because it's a legume, of course, you're going to require a certain amount of rhizobia, so a seed treatment is mandatory. And then in addition to that, in a lot of instances, you'd be looking at value-added seed treatments that would protect against seed and soil-borne diseases. Then when you move through the cycle, there's of course the sales and marketing risk of, will this variety be well received? And if it isn't, it doesn't necessarily have the sell-through desired, and that could translate into inventory. And from a seed company perspective, two bad words to have, obsolescence, and then if a variety is no longer commercially viable, there's a cost that accompanies disposal as well. So proprietary varieties certainly reward companies that take on some of these risks and bring to market in-demand products that offer value for growers. To date, Brett Young currently carries 26 proprietary alfalfa varieties that we actively produce and sell. So that's a very extensive list of proprietary alfalfas, and one that I have the luxury of product managing, which is quite an extensive job. But beyond that, when you look at our sales, over 80% of our alfalfa sales company-wide would be proprietary, and those are being sold across Canada, but then into markets like the U.S., Europe, as well as China. When you look at the Western Canadian market specifically, our proprietary sales would be higher than that. We would probably be 95% plus. Fall dormancy and winter hardiness. Annie touched on this in good detail, so I won't spend much time on this, but it's important to understand the correlation. Obviously, they're separate ratings, but they're related. You know, fall dormancy, of course, is a rating from 1 to 9, and it's the amount of regrowth that an alfalfa variety would have in the fall. Most Canadian dormancies that we would be selling across Canada are in the 1 to 4 range. We do sell some fall dormancy 5 varieties, but it's very, very limited. And, you know, as Todd said, most of those genetics would be coming from U.S. programs. There's not a lot of active breeding that happens in Canada on those. Fall dormancy 6 and higher are not adapted to Canadian conditions. Fall dormancy, when we look at high-yielding varieties in Canada, most multiple cut alfalfas tend to be in the fall dormancy 3 to 4 range. However, we are seeing some improved varieties that are showing hardiness and productivity outside of these traditional ranges. For example, some fall dormancy 3 varieties are showing some really, really high productivity numbers with some strong winter hardiness. And then similarly, we've seen even some fall dormancy 2 varieties, which would be a very winter hardy variety, showing productivity that's 95% of some typically higher productivity fall dormancy 3 varieties. So that range seems to be expanding in terms of strong, improved winter hardiness, as well as higher productivity relative to the hardiness of that respective product. So traditional breeding efforts have focused typically on yield, quality, multifoliar expression, and rooting habits. And I just wanted to include some pictures here so you could see the tremendous variability between root types. Obviously, our standard taproot over here on the left-hand side is what you would find in most traditional or conventional high-producing alfalfas. And then on the other end of the spectrum are creeping-rooted alfalfas, which are going to demonstrate typically more of a prostrate growth habit and grow horizontally. Those would typically be in the fall dormancy 1 or 2 range. So very long-lived, but not necessarily, ideal for high productivity. And then there's combinations that are approaching a combination of both a taproot and a creeping root, where we look at some branch root characteristics, such as this alfalfa here in the center. We currently have a variety that we sell which has branch root characteristics that tolerates higher water tables better. So under heavy moisture situations, it has proven quite an effective variety. And lastly, I just included this really for the image, but here you can see a sunken crown alfalfa where it actually has a recessed crown that is below the soil, which would protect it from wheel or hoof traffic. As breeding efforts have evolved, we've moved beyond some of those traditional characteristics of alfalfa, which I just discussed, and we've moved into some more unique rooting habits, such as this alfalfa variety that I have right here called foothold alfalfa. This is actually bred for a very large and oversized crown, which makes it, again, more tolerant of wheel and hoof traffic. A similar outcome to the survivor alfalfa, but with a different method of getting there. Improved low dormancy persistence, as Dr. Claessens is working on, hybrid alfalfa, and even low-lignin, which has been introduced in eastern Canada and is being commercially sold. And we're excited to be introducing a product into Western Canada in next year. So spending a few minutes on low-lignin alfalfa, lignin is a complex organic compound that binds cellulose fibers and other cell wall polysaccharides to harden and strengthen cell walls of the alfalfa plant. So as alfalfa matures, the process accelerates. So naturally, you're going to have those stalks develop more lignin as they progress throughout the season. With that being said, harvest timing will, of course, affect your yield and quality, and it will also affect the amount of lignin content contained within those stalks. Cutting earlier is going to reduce the amount of lignin that you will see, but it can also have adverse effects on the potential yield that you can get. How is low-lignin alfalfa developed? Well, there were screenings for thousands of plants, making selections based on agronomics and low-lignin content. And here you'll see over here in this red circle, the percent of lignin and as well as the dry matter yield. So the breeder was looking at high-yielding varieties that obviously had low lignin content, and selections were made from those respective varieties to create high-jest low-lignin technology, which was patented in 2017. Relative forage value, NDF, and total digestible nutrients, which are traditional tests for forage quality, do not take into consideration lignin. So there are some other tests that need to be used in order to assess how high or low lignin content the respective alfalfa variety may have. The best indicators are acid detergent lignin, which is the percent ADL test, undigestible neutral detergent fiber digestibility, and lastly, total tract neutral detergent fiber. So taking these into consideration, the breeder was able to develop a variety that, based on their research data, had a reduction of lignin in the range of 7 to 10%, had improved rate of digestion, less undigestible fiber, and higher crude protein. These are all characteristics that you could expect with lower lignin content. So what it translated into was an indication that you were going to get more milk or potentially beef per acre with feeding that type of variety. And that's what I have for you guys today.
Well, thank you very much, Eric. That was great. If you have any questions for Eric, again, please type them into the chat box now that's on the left side of your screen. We'll now take some questions for Eric. Eric, can you recap for us what you mean by the proprietary alfalfa revolution?
Sure. I didn't want to necessarily overstate proprietary alfalfa, but certainly our business, and I think a lot of other seed companies, have moved away from the common seed model, where in the past there was undefined performance characteristics and seed was largely sold unbranded. But now when you look at the market, most customers want defined performance characteristics. They want a certain element of certification, knowing their seed quality. As well, they want to know the fall dormancy characteristics or the winter hardiness characteristics, including rooting habit. So you put all those factors together, and that's one of the major drivers of our, certainly seed companies, selling largely proprietary varieties.
Eric, as far as you know, have there been any varieties selected under sheep grazing?
Not that I'm aware of. I'm probably not the right person to ask about that. I think Annie might have more knowledge of that. But most of the varieties that we license are not specific to sheep grazing.
Annie, if you're still online with us, can you provide any input on that in terms of varieties selected for sheep grazing?
I don't know any of the varieties that we produce here which has been developed for that, but most of the species, the varieties, when they go to a trial, sometimes they go to a sheep trial instead of a dairy or beef trial because it necessitates less material. But specifically developed for the sheep, no.
Eric, can you give us a quick recap of how the Canadian alfalfa seed market is unique from others around the world?
Yeah, I mean, there's a couple things that come to mind, and the first would be a lot of our seed is certified seed. It's sold with verified kind and an inspection and to a certain level of purity and germination. The other factor is when you look at our alfalfa business, the vast majority of sales happen in mixes with other grasses. Right across Canada, most seed is sold in mixes with timothy or brome grass or other forage type grasses that are complements to that alfalfa itself.
Well, that's all we have time for today. I'd like to thank our three speakers for making time in their busy schedule to share their insights and expertise. I hope that everyone's found the information valuable today. And again, I'd like to pass on a very big thank you to our sponsors, 2020 Seed Labs and CCAN, for their support. I also want to quickly thank Kyle Dradwani and Teresa Kurdziewicz, our team working behind the scenes, for their dedication to making this a successful and informative event. This presentation will be made available online at germination.ca within 48 hours, so watch for that. Thank you very much for your attention today, and on behalf of the team here at Germination, we hope you have a great rest of your day. Bye for now.